Welcome, everyone. Thank you for joining us to this DVCon panel, the second one. And today we are talking about chip design on cloud, from pipe dream to preeminence. I'm Ann Muchler, Executive Editor for EDA at Semiconductor Engineering. Just a quick reminder, please ask questions in the Q&A tab. You can find that at the bottom of your screen, as opposed to the chat. There's chat and there's Q&A. Please use Q&A. That would be very helpful for us. And I also want to give a special thanks to our organizer, Sashi Obolasetti from Google, for organizing this panel and inviting me to moderate. So let's get started. So Gartner predicts that by 2025, about 80% of the data centers will move to the cloud. Some of the inherent benefits of the cloud, such as elasticity, fault tolerance, and security, cannot be matched really by on-prem data centers. Cloud is already the data center of choice for several industries, from retail to banking to manufacturing. Chip design and verification on cloud, we've been talking about this for decades. I can remember covering this at least 10, 15 years ago. But today's cloud is very different. So we are going to delve into some of the issues surrounding chip design in the cloud, specifically what is the state of where we're at today, whether companies are designing successfully, what works, what doesn't work, as well as the all-important licensing models. We have a great group of panelists who represent multiple segments of the chip design industry and will be sharing diverse views. So I would like to start introducing our panelists, and I would like to start with Megan Wachs, VP of Engineering at Sci5. Welcome, Megan. And I wanted to invite you to give us a little bit highlights of your background and how you're looking at chip design in the cloud today.
Thanks, Ann. My name is Megan Wachs, and I'm the VP of Hardware Engineering at Sci5. And so Sci5 is an IP provider, and we have a very wide portfolio of RISC-V core IP with a lot of additional items like debug and trace IP and related collaterals. And the way that we deliver our IP is through the cloud. We have a website called Sci5 Core Designer, which is a interactive platform where customers can come on and configure their design, select their options, and then we run everything on the cloud to bring them, a verified IP that meets their requirements. And so we're coming this from we are both kind of a consumer and a provider of cloud to ourselves. We are running tools, as many tools as we can on that cloud-based platform and providing that experience to our customers. And I'm sure we'll talk about it more today, but to be honest, we cannot do everything that we want to do in that flow. So we do have to kind of bring some things in and provide part of the experience is kind of done not completely on the cloud in the customer's hand. And one of the big advantages that we get from this cloud experience is that the customers never have to install tools or anything. We just roll out regular releases to the web, like any other sort of web-based platform that you're used to dealing with, and they get the latest and greatest features from our IPs and or fixes, and all that's done through our Core Designer platform.
Perfect, thank you. Next, we have Bob Lefferts, who is a Synopsys fellow. Bob, can you, first of all, welcome, and you're on mute, by the way.
Thank you.
Thanks. Could you share a little bit of your background and also your perspective on?
Sure. So I was acquired by Synopsys about 17 years ago. I was an engineering director at a small startup doing high-speed SerDes and started working at Synopsys, which at the time was mostly an EDA company, and now it's a lot more. We're doing EDA, we're doing a lot of IP, we're doing software integrity and security, optics. We sell optic software, all kinds of stuff, and all the device level simulations. And I work for the part of the company that does IP. So similar in terms of Megan, in terms of using all the EDA tools as a user. Unfortunately, I get them all for free, which is really convenient. We do a lot of IP. I think in 2020, we did like 18 different foundries, 40 different technology nodes with all the variants, taped out 50 chips to verify our IP, and delivered about 900 IP blocks to customers. We have about 1,000 layout engineers and 1,000 circuit designers all working at Synopsys all over the world, 16 sites. The IP group is about 6,000 engineers out of the 15,000 that Synopsys has. And that's what got us into the cloud. We acquired about 500 people that needed a place to work. And one of them had been working on the cloud for 6 months. So that's what got us real quick start. It was about a year ago. To get up and start doing chip design on the cloud, but not their way, our way. So we had to move our environment up onto the cloud. And then the other couple 300 people were in the spring, right in the middle of COVID, where we couldn't build the infrastructure on the ground. And so we had to come up with a quick solution to copy our design environment up into the cloud. And so it was been a very interesting year. We learned a lot. So.
Perfect. Thank you. Next is Eric Chesters, and he is a fellow and AMD. Eric, could you give us a little bit of your background and share kind of your overall thoughts on chip design in the cloud?
Absolutely, Anne. Thank you very much. As you say, my name is Eric Chesters. I'm a fellow with AMD. I've been with AMD for just over 3 years now. I work as part of our central methodology team, so I work with all parts of our business, the CPU core design guys, graphics, IP, SerDes, the whole portfolio. My particular focus is on really more what we characterize as the front-end design process, everything from release management, build, VCS builds, regression, test infrastructure, etc. One of the things we started looking at the cloud sort of middle of last year, really looking to see as the company grows, clearly our appetite for more compute grows with that. And what role can cloud play in augmenting our on-prem data center? I mean, we've got a large established on-prem data center, but our ability to rapidly deploy new CPUs, deploy more capacity, certainly is nowhere near as agile as we believe we can be with the cloud. So our strategic initiative really for this year that I'm spending most of my time looking at is how do we enable that? How do we get not just into one cloud, but be multi-cloud and give us that agility to push workloads out into the cloud and over time, obviously optimize those for cost and latencies and all those sorts of things.
Perfect. Thank you. And we're going to talk more about that. And rounding out the panel, Richard Ho, Principal Engineer and a Director at Google. Welcome, Richard. It's great to have you here. And could you give us a little bit of your background and your perspective on EDA in the cloud?
Right.
Chip design in the cloud, not just EDA.
Thanks, Anne. Yeah, well, EDA, I started my background in EDA. I was a co-founder of ZeroIn way back when, dealing with CDC and formal verification insertions. But soon after ZeroIn, I moved over to the customer side, started in design. And at Google, where I've been for about 7 years, I've been basically working on the TPU accelerators for ML. I've worked on them for multiple generations. I currently own kind of design, verification, PD, mostly the front end, but also part of the implementation as well. So, when I joined Google, I thought Google has data centers. And so, having infrastructure for our compute was going to be simple. But it turned out that Google doesn't like having third-party black box executables running on the same servers as Gmail, for example, right? They can't trust us. And so, infrastructure turned out to be a bit of an issue for our chip design team at Google. And so one of the first things that we thought about was moving to the cloud. And so we've been on this journey to move our chip design processes onto the cloud for several years now. And I can say that, our TPUs are designed on the cloud. We do use GCP, our cloud services, and that is how I actually do our design processes. So I have a fair amount to share about what works and what doesn't work, and we can get into that in the panel as we go along.
Perfect. Well, and we'll just jump right into questions. And at the end of hopefully the last 15, 20 minutes, we're going to reserve for questions from the audience. So again, another reminder, please start asking some questions. That'd be great. So the pandemic, this has really thrown a lot of things up in the air. Bob, you touched on a lot of this or some of this, and I'm curious to hear, what's really the impact of the pandemic been on your interaction with the cloud, your customers' interactions with the cloud, depending on where you sit with that. So Megan, do you want to start?
Sure. I mean, I'll say even before the pandemic, Sci5 has been we're a disparate company. We are across the country, across the world, and we were very used to working remotely, using kind of, I guess, the latest like software platforms for collaboration. We use all these sort of cloud-based platforms ourselves. So I would say that actually it's been a fairly smooth transition for us because we were so used to working that way. I think maybe kind of a lot of the people in the sales organizations felt very different because they're used to going face-to-face and helping. But I think, again, having this like nice platform that they can, help walk the customer through, even over a Zoom call or whatever, has lessened the impact on them. But I'd say overall, from a technology standpoint, it felt fairly smooth from our perspective.
Great. Eric?
Yeah, I think similar story. I mean, obviously, we've all been experiencing most of our human contact through the cloud in many ways since this time last year. So I think people have become very familiar with it. Along with that, I know it's caused us to accelerate the adoption of some platforms and also look very carefully at what we're doing with our security in terms of just seeing a lot more content outside of being the EDA engineering space, but a lot more content being cloud hosted. That certainly has made people very aware, and I'm sure we'll talk about it later. And I already see some questions in the chat.
Mm-hmm.
When I go out and talk to our IP teams, the first question I get is, is it secure? Because they've been fed this diet of, increasing security measures covering, collaboration through document sharing, Teams meetings, these sorts of things, etc. So it's heightened people a little bit to the security questions. Something that's the first one that tends to get fired back at us when we go talk to a new team. But overall, I think the adoption's been fairly smooth. In terms of our engineering day in, day out effort, we're just beginning to see, workloads of any particular significance transition into the cloud. So we'll get a better view of that in the coming months here.
Great. Richard?
So, I think that we've been operating kind of on the cloud for a while now. So for us, the transition was really smooth. The interesting thing is that, we still occasionally, have some stuff that's running on-prem or on individual workstations. And when they crash, it turns out that it takes like a day or two for us to get someone in security to go into the building because we're not allowed back in our buildings and stuff, to actually reboot our machines and things like that, right? And so being on the cloud has actually been a win for us in the pandemic. And, I would say that our productivity as a team has been actually very good through the pandemic, right? I think it's been hard on everybody individually. It's definitely, a mental burden to have to work through, Zoom or Google Meets or whatever. But I think in terms of the team actually getting work done, it's actually been very good, on the cloud during this time.
I have actually heard that across the board with all sizes of companies, from startups to, established companies. So, Bob, any more thoughts on this? You shared a little bit. You're still on mute, by the way.
Oh, geez. So I think for us, there's a couple things that are quite different from the pandemic perspective in terms of things that have changed as a result. One of them, of course, was that at Synopsys, we don't talk about working from home. We talk about sleeping at work. It's, in some cases, people had long commutes to get to the office, and now it's the 30 seconds. And so all the measures that we have of productivity and output and bug fix and everything have gone up, not down, but it has been stressful in terms of just the amount of work that's getting done. It is the day starts really early and ends really late, and you don't get that downtime of commuting. The other thing which we've seen that's quite different is that we, especially in some of the, cheaper locations with a lot of our resources are in India, particularly where they weren't allowed in the office and they had to work from home. The foundries were, in general, historically, not okay with people doing layout from a non CCTV area where they're sitting at home with, you know, an 8-year-old looking over their shoulder. And so that was something that we had to work with the foundries. That we didn't have a choice, right? Either everything stops or people are working from home. And that was a pretty big factor for us. And that's still a big factor as far as security goes. You can build a cloud so that it's very secure, even more secure than what's on the ground, because you can start with everything closed and opening up spigots that you need to get in and out, as opposed to having it kind of wide open historically. But in general, the cloud does bring some security issues in terms of some of the services that we're now using aren't inside the building, which means you've got to poke holes to get out to those services, and now you can't restrict where people are connecting to those services, and it does raise security issues in terms of screen capturing, screen sharing, video, that kind of thing. So we've been working through that.
That's really interesting. Let's just stick with this security topic because I think that there's more to talk about here. So depending on where you sit, I'd like to hear more about what are the concerns from your point of view? What do you need, or what are you providing to customers or users to give them the sense of security as well as the actual security that is necessary today?
I can start with that one. I think, you know, for us, I see a comment actually in the chat, which I completely agree with. When we see cloud or talk about cloud, people think of very different things. And some places you think about cloud as this thing that sits at the other end of Office 365 with a very public interface that you can log into from any device anywhere in the world. And that clearly raises a lot of concerns, and that's where we've seen a lot of augmentation of the security surrounding that come into our usage of those services over the last year. But for us, when we talk about cloud from an engineering perspective, we really view it just as an extension of our on-prem data center. There are no public interfaces. The only way in or out of that cloud is through the secure connection back to our Atlanta data center, which is our main one that we have at AMD. So I think, you know, getting people to the point, you know, both internally that we believe that, and we've done all the due diligence and partnered with the cloud vendors to hold that statement. You know, that's the way that we're tackling that question within the company, is really saying to them that, look, from the user perspective, from a security perspective, they should view it as just being an extension of our on-prems, like another AMD data center that happens to be hosted in one of the cloud vendors, rather than being something that they would connotate when we first start talking about cloud in these other applications, for example.
Okay, great. Megan.
Yeah, and I think you asked, like, giving confidence to customers. I think using the cloud and, you know, industry standard tools for just giving customers access to machines through the cloud is kind of the right way to do that. We wouldn't want to necessarily roll our own web servers and host our own things there, because we're leveraging, you know, we're standing on top of the shoulders of all the technology that is out there with, you know, companies who are targeted on providing security and, you know, these sorts of platforms where we can just put our interesting, you know, chip design relevant stuff on top of that and not have to, you know, hire an entire team to do security. And then I think is like, if I was a customer, I would be more confident knowing that we were using, you know, real cloud providers and not, you know, hiring our own team to do that sort of thing. So, I think but on the flip side, we do have, as a consumer of, you know, things like technology libraries and stuff, when we want to do our own like performance analyses, we so far generally have done that through our own on-prem or, you know, in server things that are not in the cloud. And so we're still working through gaining the confidence of the foundries and everything that our servers are data centers are secure, and they have their things that they're looking for. And so I think that's one place that is still a little bit unclear which way you should go if you're getting into this right now, is when you're doing these things that are, it's not yours, it's not your customers, you have to convince the person giving it to you that you're saving it, storing it securely. I'm curious about other panelists' experience on that front.
Richard or Bob?
Yeah, I was going to jump in here. Although I'm in the unique situation of working on my own company's cloud, security has still been a major concern for me because of the nature of the project that we work on and some of the rules and regulations around that. And the way I view it is that if I was working with my own data center, if I was in a company that was not Google, for example, I would have to be very confident in the security setup of my IT, right? Versus in the cloud, and this applies to on most of the public clouds, but in Google in particular, there are a bunch of people who are security focused. There are teams of people who are there, and their job is to basically secure the cloud for all the customers, including myself, right? And I would prefer to have a set of dedicated people whose job it is to securely, work on research and security, look for the zero-day exploits, and basically be monitoring for all the different open ports or other things that people have done in configurations that are wrong, and constantly monitoring. And so I actually feel safer being in a cloud than being on a kind of an on-prem network where I would have to rely on my IT and get with it's probably going to be fewer people than working on a public cloud working on security.
Great.
Yeah.
Bob?
We've been working on security for quite some time because we get a lot of data from third parties, primarily foundries, in order to give us collateral that we can use to design IP. And so we've been working on that, and over the last 10 years or so, we've gotten a lot better at the little things, like, for example, only giving people access that have a need to know, and how we define need to know, and everything that they get access for expires, and they have to get re-vetted to be put back into the access point. So we've been working on that for quite some time. I personally remember signing an NDA with one of our foundry partners that said, you promise to never ever access anything at our company from Starbucks. I was saying earlier, I don't have coffee at home, so occasionally I do visit Starbucks, not with my laptop anymore, but that was one of the things about access, remote access, and being able to have people shoulder surfing and looking at the screen. Well, then everybody had to go home because of COVID. And so there are ways to different levels of security between someone getting access to large file transfers, which is a problem on the ground, or on the ground when we get go through verification with some of the foundries. They come and inspect our premises and make sure there's locked doors and key cards and guys with shotguns and things like that, right? They're not doing that on the cloud, but then your access point and your screen becomes a whole nother scenario, right? So originally when we started putting people up on the cloud, we tried to do so in a way to save cost, and ended up having to redo it because of security concerns, in that the way that they were connected to the cloud could be shared and you don't know who's connecting now, right? So that's one of the things that we've been working very hard on, is making sure that when you connect to wherever, whether it's to our on-prem hardware or onto the cloud, no one's in the building. And we're not worried about people walking out with boxes. They can't even get in the building, right? But that used to be a concern in the past. Now on the cloud, of course, you can't get to that box either. So it is better in that way. But in my experience, that it's been easier for us to get permission to put third-party collateral from our foundry partners on the cloud than it is to put them on the ground, because they have to worry about someone picking up the box and walking out with it, right? Yeah, you still have to be very careful about who's accessing what and how.
Sure.
The flexibility of the cloud allows you to do that in some cases, because you get a lot of our experience of people on the panel have been at the companies a long time, and the infrastructure on the ground is old and has, certain holes poked in the Swiss cheese that, when you start on the cloud, you can start with everything closed. So there are some advantages to moving, but it's also difficult in that as you want to move, you have to be very aware of you're paying for the straw, right? Data going through the straw, it costs you money.
Well, so this seems like it's connected with understanding what you should put in the cloud and what you shouldn't, what you should process in the cloud and what you should process on-prem.
So that is a challenge, but of course the obvious thing, right, is that what you put on the cloud is when you ran out of hardware on the ground and you need to do something, you need to put it on the cloud. Now the problem is how do you get it there, and then you pay for when you bring it back, right? The other option is put everything on the cloud. Now you don't pay for the up and down, but you got to pay for it being up there, and that's more expensive. And so, yeah, that's a continuous, it's the trade-off between I've got a giant workload that's going to come and go away, and if I buy the machines on the ground, that's stupid. But if I have to get the data up there, run just this one job for the next 3 weeks, and then it's going to come back down to zero, I've got to transfer everything up and back. So it is a trade-off. There is definitely, that is a real part of figuring out what's going on. And fortunately or unfortunately, the way the cloud service providers work is they charge by the pint of blood, right? And they don't necessarily where it came from, who drew the blood. They just say, this is how many pints you owe me, and you don't know where it came from. So the whole cost accounting has been a rather interesting challenge, not just from a Google provider, but from internally in the company, having those cost controls in place, because we're not used to paying for hardware, right? And normally if you go say, hey, look, I need 1,000 cores for 3 weeks, we don't have them. Well, now you can get them, but how are you going to pay for them? So it's an interesting, the flexibility brings an interesting cost accounting challenge.
I actually like to jump in here with our experience, because we actually care about that. We actually care about the cost on the cloud as well. We get charged as well. And we worked a lot on the infrastructure for that, because we saw exactly the same problem, right? Where do you store your data? How much ingress, how much egress do you want to use? And we actually designed our system and our infrastructure to basically hold our repos on-prem in our local areas that are within the corporate network. And we basically move the data up to the cloud to do the processing. And we try as hard as possible not to egress as much data out of it. So, if you want, you egress reports, light reports, you don't egress entire databases out of it. And you basically leave it in the cloud, or delete it and regenerate as you need to. But we actually did spend a fair amount of time thinking about that in order to make that cost effective for ourselves as well, right? So I think if you are a customer thinking about that, I think those are important things to think about. What storage you're going to be using up there, what your egress, and in particular egress, because the egress is actually, I think, the more expensive thing. Ingress is actually relatively cheap and relatively fast. And how the workflow works. Because I think that, the other thing is that your engineers will kind of have this little change in their workflow working on the cloud, even though it is an extension of the kind of data center. If you have to get data to the cloud, it does cause a little bit more latency. And so you do have to work that into the workflow and get people used to it and train for it as well. So I think those are kind of the, on the ground details that kind of change as you make this migration, as people make this migration.
Great.
Yeah.
Eric, you're shaking your head.
Yeah, no, I mean, when we started looking at this, obviously as AMD, we come in and the first thing we think about are the compute nodes, because that's what we build and that's what we're trying to sell. But very quickly, the mantra, with me and the people I'm working with this on was, became, it's all about the data, understanding the data, especially with flows that, have been built to run on-prem for 20 years and assume that they've got instant access to any piece of data in the whole data center. So even just identifying, what is a piece of work, what data is actually pulling from, which file systems, where tools are being retrieved from that particular task is using, etc. There's a lot of challenge there. And understanding, what do you want to move up? How do you manage it? What's the lifespan? What do you want to pull back? And there's a whole range of answers there. Certainly for some of the workflows I look at for, BCS, etc., or for simulation workflows, some of those are very amenable because, we push the models up into the cloud, we run the tests, some are running in bulk regression mode, and we're getting pass, fail, and a seed and a signature potentially. A very small amount of data coming out because any debug of that failure is done offline. Waveforms would be collected by rerunning, etc. But then you get a question of coverage information. If I'm collecting coverage, what's the lifespan of that coverage? How do I manage, combining that? And if I'm also running still on-prem, the merging of those things. So data is really the thing that we spend the most time thinking about, both initially, but also in the longer term as we start looking to cost optimize and optimize the user experience. Where's that data coming from? Where's it going to? How's it being held? But that's going to be what we're talking about for the next few years here, I think.
Okay, great. Megan, I know that you, from what I've learned from you, that some things you do for customers happens, in the cloud, but then some you also pull back. So how did you decide what needed to happen where?
Yeah, for us, I think a lot of it is licensing issues. There's certain tools that we can run on the cloud, no big deal, like open source tools or tools that have a reasonable licensing model. And so we do as much as we can of that sort of thing. And then there are other things that, mostly from a licensing perspective, we wanted to use, VIPs and things like that, that we don't have, at least on our like web connected customer facing cloud. So we, internally, we also use the cloud to do things like you said, like coverage runs and stuff like that. Some larger running jobs, we might spin up cloud instances to do things that, are kind of bursty. One thing I wanted to say is that I think, like Eric was saying, the problem you all have to solve no matter what is dividing your workflows up into things that can say what their inputs are and what they're producing, what they depend on each other. And then it's like, once you do that, you can move things around internally. You can make sure that when you bring up a server in India that you want to be on-prem there, like things will still work there. All you have to do is set a few variables. And that is really something we've been focusing on a lot in our internal flows, is just really making the flows modular and not assuming and relocatable. And if you do that, then you can kind of pick bits and pieces up onto the thing. And we're starting to actually have more of our internal flows using the same backend that the customer-facing web flow uses, because then it's very, sealed. Like you don't have this problem where verification engineers are like, I found this bug, but actually they had some weird test case. The change is not there. The designer's all angry. So, it goes both ways, that we're trying to get our internal flows to use more of the customer-facing things because it is so like hermetic, I guess.
Great. Well, you mentioned licensing, and let's jump over to that, because I think that a lot of people want to understand what should this look like today? How should we license, let's say, EDA tools in the cloud? What does that look like? What should it look like?
I can say something first from just as a consumer side. I know, like, when we want to spend money on something, to do something bursty, we just spend the money and we get the things. And, like you said, there's cost accounting, and we, go to our IT, and there's a way to do that. The licenses are difficult. And like, if we're doing something, we have to cache in tokens, and one time somebody accidentally cashed in 25 tokens when you're supposed to cache in 2. And it's like, how is that even possible? It's just feels very manual. It doesn't have the same, thing that we're used to. And we have, we pay for so many different services that aren't EDA things. And so there's like a model that we're used to. It's like, we do this, we add a user, we pay more for the user, but we don't have the same thing with the EDA licensing yet.
Okay.
Yes. I would say that we're in this early phase of kind of moving over to the cloud from the business model, from an EDA licensing perspective. Because ideally, right, when you want to burst, and for example, in our flows, when we burst, it's about doing things like coverage closure or regression runs, right, where that you just want to get a lot in a very short amount of time, and we can burst up to 10x what we would normally run on a nightly, for example, for some period of time. You want to have the licenses to support that. You don't want to be paying for that 10x licenses all year, or all 3 years, in fact, on most time-based licenses, right? And so I think that what's important is to be able to get a licensing model with the EDA tools that allow you to have either a pay-per-use model, or have a very rapid ability to kind of monitor what you use to pay for it, or to very rapidly add and delete licenses. Right now, the process of adding and deleting licenses is not that simple, and there are glitches that show up as a result of that. But I think that's an area where I'm hoping that the EDA companies will pay attention to this move towards the cloud for chip design, and respond in a good way. And conversations I've had with them have been very positive. I think they're eager and open. But I think we have to figure out how to make that work for everybody, right? We want to make that work for both the EDA companies as well as for the customers.
Exactly.
Well, as the guy from the EDA company that doesn't have to pay for the licenses, I have less of
Everyone is
less
jealous,
of a problem. I definitely can say that as a result, we're extremely focused on the cost of the hardware because we're not paying for the software, right? And in general, the IP team at Synopsys, unlike some of the other business units where there are, releases on certain scheduled dates and they have much more of an up and down and they're doing a regression and then they repeat the regression over a certain period of time. We tend to just run, I think we ran over 1 billion simulations last year. We have about 100,000 cores and they're running about 85% load average. They just run all the time. And what ends up happening is you just get accustomed to doing your work. Okay, let them go, throw them on the grid and then go do some other stuff. And eventually they'll come back. Right. So it's very constant utilization of the cores. That's not typical for some of the other business units where it's much more erratic. But we have moved 10% of our cores onto the cloud. Right. And they just pretty much run continuously. But because we're so focused on the hardware costs, we've been really pushing the use of the spot or preemptive cores because they're so much cheaper. From a licensing perspective, I mean, from an EDA standpoint, I know that all the EDA companies are very customer focused, and so I know they're talking to Eric and Richard, and we'll figure this out, right? It's not a question of if, it's just a question of when, and making sure that somebody doesn't make that mistake. I remember years ago where some marketing guy decided they were going to give away coupons for pudding. And then some guy ended up buying the whole state out of pudding and got 1 million air miles because they never did the math that said, if you do this, it's cheaper to buy the pudding than it is to buy the plane ticket. And we EDA companies don't want to give away the software for free by mistake. Let's put it that way. You only get to do that once in your career, I'm pretty sure. But there will be a model that makes it work, right? The problem, of course, then not only that, but now there's a cost associated with it. It won't be free. I can pretty much guarantee that. And we've had a problem where, a guy in IT basically say, I'm going to run an experiment. And he blew 60 grand in 2 weeks when no one was watching. And it's like, what are you doing? And he's like, oops, and so that's going to be a problem when you've got a flexible model and then somebody runs and you didn't set the voltage right. You just wasted 3 days. Now, yep, that's going to happen. And there's that, So one thing that Synopsys has been working on, as I mentioned, we run a lot of simulations on an annual basis, is that we are, from an internal perspective, to the point now where when we charge the business product line, we know exactly how much CPU resources they're using. And so they're getting directly charged. That didn't used to be the case, right? You could take whatever you want. No one was asking you to pay for it, right? And so you have to have that part of the culture in order to really effectively use the cloud and not waste a lot of money. You need to know that relationship between, I'm going to run this job because I can, or as opposed to this is what it's costing me, right? Mm-hmm. So that'll be a transition as well.
Yeah, definitely. Eric, what would you like to see with licensing models?
I think I agree with the other panelists. I mean, I think the cloud, what's the promise of cloud is this elastic model that allows you to dial up, dial down. I think, Richard, you said that absolutely, if you're doing chip development, there are times where you need more. You're trying to close coverage. You're trying to get the final regressions in. The cloud offers, the promise of that elasticity to take on 10,000 extra cores for that period of time. And there is just from what I've seen, still an impedance mismatch between, the ability to provide the hardware versus get the license keys to go with that. So I think it's something that, we've seen other parts of the software industry transition to more of a subscription model, whether it be Adobe or Microsoft, or, who'd have thought Microsoft would be selling you subscriptions to Office 365, even 10 years ago when, they wanted you to buy the CD. So I think we'll see that come. It's going to be interesting to see which of the EDA companies flinches first and really makes that big step forwards. I think the governance model, both on the hardware and the software, yes, we're not looking at that yet, but clearly, yes, with that elastic capability comes danger. And how do we stop our users shooting themselves in the foot with that capability and use a whole month's worth of allocation in the first 2 days of the month because they got a bit carried away with the regression over the weekend, etc. So I think there's going to be a lot of lessons to be learned there surrounding the governance, and some of those are going to be quite painful lessons to learn, I think. But it's going to be interesting to see where it goes.
Definitely. We have a lot of questions coming in, so let's go there. So there was one interesting one here. Does anyone have any customers in the defense industry that you're even allowed to say that are using the cloud? And has the NSA been involved in any of the security, which I think is a really good point?
There has been some discussions on that. I used to work for Cisco, and I know when I was back at Cisco, we got pulled in because there was conversations happening between Cisco as a cloud vendor or technology vendor and the various parts of the Defense Department looking at establishing a cloud presence actually for defense work. Where that is today, I don't know. It was just a discussion I was pulled into.
So I know enough to say that it can't be talked about. Let's put it that way.
That's what I figured.
So for those of you that didn't understand what I just said, it's a yes, but not really from me, right? In other words, can't talk about it, right?
Oh,
but
really
yeah,
not really.
Understood. Well, I think I did say earlier that you can make the cloud extremely secure, right? Mm-hmm. We have done that, and we know we can do that, and so other people are going to figure it out. Let's put it that way.
Yeah, thought it was a good question. All right, so let's see another question here. Did you have to build a lot of custom tools on top of the vendor supplied tools to allow for cloud development? I'm assuming, yeah, so they mean EDA tools.
So I can take.
Go ahead.
Bob, you want to go first?
No, go ahead. Go ahead. Right ahead.
Okay. So I can say that we did build some infrastructure, and like I said, we were a bit early. So I think we were doing this before a lot of cloud services were actually even built out fully, at least on the Google side. But a lot of the services are there now. But the main thing you have to do is, for us anyway, so we use kind of a hybrid model where our repo is still on-prem. And basically the infrastructure we needed to build out was really the marshaling of the data that was going to be sent out to the cloud. We wanted to basically put it into a container, move it out there, and then just basically be able to run it. And that also added a little bit to the security aspects because what's out there is a little bit more jumbled, a little bit more obfuscated than just a clean repo. And so that's the way we did it. And so we had to build that sort of the infrastructure. There was a little bit of infrastructure also on the cloud where we're basically having to marshal the data around so that when the waveforms were generated in some place, you knew where they were, and so you could actually log into VM and actually look at this stuff like that. And we have done multiple flows. So, we do verification flow. We've done a formal property checking flow and a PD flow. Each of those has slightly different bits of the, marshaling that are needed and slightly different data management. One of the interesting ones was that on the formal property verification, a lot of the tools, they actually, within the process, within the job, spawn out other jobs, right? And that's a little bit different from simulation and from other things. And so we need to have a little bit of a, just modification of the configs and stuff like that in order to do that on the cloud efficiently, where they would pull up, other VMs to do their job rather than just spinning onto another, into more cores.
Interesting. Megan, you want to share anything here?
Yeah, I mean, I think, like I kind of alluded to earlier, there's a lot of work in tooling around the flows. So we have our own internal build flow tool that kind of manages modularizing everything. So I think that's one of the biggest things is just the flows themselves have to be really well designed so that it's easy to move things and sort of seal them up. Yeah, and we haven't written our own custom EDA tools or anything of that nature.
Great. Another interesting question here.
Sorry.
I was going
to say that when it comes to the infrastructure part, right? So one of the things that happened in our case, and I think Richard talked about being careful about what you move up and down and containers and things. We were on a very short timeline to get 250 people, 300 people working on the cloud in our environment. And so we really focused more on making the cloud an extension of our on-prem infrastructure. Okay. And fortunately, over the last 10 years, we've worked very, very hard to have one way to do things that we can improve over time instead of each team doing it a different way, because there would have been no way to move that quickly. We were actually able to bring up our design environment in about 3 weeks, which I would have told you was impossible, but we did. And so that was just literally moving what we had on the ground up. And a lot of the work that we're doing, by the way, is layout, right? Which is very manual. It's not tons of hardware. You need the machines, but it's not like running a big regression where I need 1,000 cores, right? I need 1,000 people to do the layout, not 1,000 cores. And so that happened. But where we ended up with the infrastructure was at looking at the costing and what we were spending and where it was going and how to minimize the hardware cost. And so we ended up not restricting the amount of data that gets moved up and down, although it turns out it's not that bad right now. Our ingress, egress, our cost of the cost of what we pay for moving things through the straw between Synopsys and the cloud is roughly around 4 to 5% of our total. And mostly, again, like it is on the ground, you're paying for compute, you're paying for CPUs, you're paying for RAM, and then eventually disk. The problem, of course, is when you run out of disk, everything stops. When you run out of compute, things slow down. And so it's upside down in terms of the cost of the disk as far as its priority goes. And it's nice on the cloud to be able to flexibly add it, but the appetite that any engineer has for disk, it's ridiculous, right? Yeah, it's ridiculous. They will use disk. They will find spare open spaces anywhere. And so that's one of the things we're having to control. And in order to control our costs, we have had to modify our policies on the ground to much more aggressive auto delete, much more aggressive keeping track of the data. Is this scratch data that's going to go away? Is this stuff I want to keep? And that stuff you need to know, otherwise you're going to be paying for it.
Yeah. I think that goes along with the question here in the Q&A. How well do large footprint, meaning large memory and compute heavy jobs, such as full chip simulation, perform on the cloud? Has the cloud caught up with on-prem capability?
I think we can put large footprint jobs into the cloud by using the specialized instances. I think where the bigger challenge I see at the moment actually is, on the verification jobs, getting cloud instances that are multi-core, that have enough memory on them to actually keep all the cores busy doing work. Just the average gigabytes per core, typically we see as 1, 2, maybe 4, whereas on-prem we provision 8 gigs per core as a minimum. So that's one of the challenges. Maybe not can I get a terabyte machine? Yes, you can. But if I'm going to have a whole bunch of machines running my DV jobs, do they have enough memory on the available instances to really keep all those cores going, or do I run out of memory? Maybe because the EDA workflows are just using a lot more memory per core's worth of work than typical cloud workloads are.
That's fair. I mean, we're not doing full chip, so we're just doing IP, so it's a little bit smaller. But I agree with the comment that what we're using in the cloud is less RAM per CPU than we use on the ground by quite a bit. You've got obviously large memory machines for the jobs that really require it, but in general, we're in the 4 gig per core for most of the stuff, 8 gig, and occasionally higher. We have to keep it down to that level, or it's just too expensive.
Okay, so is it possible though that you could get the cloud provider to do more RAM per CPU then?
So you can, but again, like I said, the CPU is the most expensive, RAM's next, and
Right.
then disk last. And so you got to be aware of the cost, right? You can do it. If you need it, you can get it, no question. The other thing which I will comment on is that we have done benchmarking on terms of disk read and write access and CPU workload. We run it on the ground, we run it in the cloud. And after a couple of hiccups and bumps or whatever, it's pretty similar. We're not seeing a large discrepancy in terms of what we can accomplish on the cloud from what we're on the ground, other than be very careful about memory. And the other thing I think is also important is on the ground, we can buy a box with a lot more memory than we need, and it's not that much more expensive. And therefore we can be on the high side memory, and then people can submit a job and say, I need 60 gig of RAM when they have no idea what they need. And it's not that bad. But now if you go and you say, I need 60 gig of RAM when you're only going to use 20, it's going to cost you, right? And so knowing what you need is no longer a nice to have. It's truly part of the workflow needs to be, I need to know exactly what this job requires and how do I do that? And that's where we're using a lot of AI today.
Oh, Interesting. Megan, do you have thoughts in this area?
I don't think so much, not to add much to what.
Okay. Do you guys do any of that kind of analysis, you know?
I mean, we do. I would say it's probably much less than you guys are. You know, we are, you know, it's more of we're still a smaller company. We don't have a lot of departments that we're trying to allocate to. So we're working together, and it's less of a headache so far for the accounting side.
Great.
I was just going to add that, you know, from our flow viewpoint, we have multiple flows, and some of them have very large memory requirements. We've been able to find the VMs. The other thing that we found was nice, which came as a bit of a surprise, because we didn't think about it too hard, was that we were able to swap VMs for certain regression runs and get more efficiency from that, because we wanted to either have a higher, higher frequency, higher speed on the CPUs. Some jobs we didn't, and so we could use a slower VM type. And having that flexibility in just being able to change configuration was actually very, very nice for us.
How do you know when to do that?
So I think, as Bob said, you need to know what you're doing. Your engineers need to know their workflows. They need to know exactly the jobs they're running and to gather the data and to refine themselves. So we kind of understand what our workflows are, and we have reasonable predictions on when we intend to spike and when we are okay and don't need that.
Eric, you have thoughts here?
No, I think I agree with everything that's been said. I mean, knowing what your jobs are doing is key. I think one of the things that I've been looking at actually this week is when we run on-prem, there's such a mix of workloads on those machines that things tend to cancel out. Big jobs, small jobs, CPU intensive, memory intensive jobs, they're all running on the same farm. They all kind of, get loads scheduled across the farm. And, it gets hidden in the noise, some of these concerns. But initially, certainly for us, when we're looking at putting some target projects onto the cloud presence, all of a sudden you start getting a lot of one flavor of a job, or two very bimodal flavors of job. And that's making us look, much more at some of these constraints about, okay, do we really know how much resource this task is taking? And some of the EDA tools we have following conversations with the vendors, because, they say this job might take between 1 and 32 gigabytes. We can't tell you how many, but just give it 32. Well, that exacerbates this problem of, well, if there's not enough memory per cores on the hosts, and the jobs will say, well, I might use up to 32, but on average, I'm going to use 1.5, then that produces a lot of issues with just trying to get the utilization of the hardware up. So certainly makes you look at these aspects with a much finer tooth comb than perhaps we've done in the past.
Yeah, good point.
Well, and one of the things that we've had to do, we've got some of our simulators now, they're able to, basically save and restore, so you can run them on a core that's going to disappear, spend a lot less money on the hardware, takes a little longer because you got to restore them, but it's not the same as starting over. And again, watch the memory footprint and then try to use the cheaper cores definitely helps.
Great. Interesting. Okay, so another question here. Do you see EDA tools being architected for the cloud, such as, web-based interfaces, flexible mapping for processes to cores, new tools for managing netlists, results data, etc.?
Yes, I think we mentioned the data. I mean, that's certainly, for me, one of the things I'm thinking about and talking to some of the vendors about is things, again, the more in the simulation world, we're generating waveforms or we're generating coverage databases. Can the vendors actually start to really help us out there by putting native interfaces into object storage or cheaper forms of cloud native storage to handle the management of that versus all of us writing our own script layer to do that for ourselves? So in that aspect, my answer is yes.
I see this as an opportunity for all the EDA people in the audience to jump on this. I think there's a lot of opportunity here to further optimize the cloud model.
I don't think there's a lack of opportunity, period, because what you're finding is for those things that don't move to the cloud, they need to move to a cloud on the ground. I don't know what you call that. I guess it's fog, right? But basically, one of the things that has been happening historically in the on-prem case is that you're not doing the same job that the cloud's doing in terms of availability of hosts and make them available when people aren't using them. They're cheaper, and we've got some people where there's hosts that sit idle, which of course isn't good for the planet in general. And so what we're doing on the ground is we're starting to follow the cloud model on the ground and sharing computers between different business units and trying to get the utilization up so everyone's being efficient, right? That's the whole thing. In the end, whether it's on the ground or in the cloud, you need to be efficient. And we haven't had to be that much in the past, but it's getting to be where you need to be, right?
Yep. Good. So we have 4 minutes left. I want to ask about some of the non-technical issues in the cloud journey. Non-technical issues. Yes.
I guess I can start off one. Our transition happened a little while ago, but we were very worried about it. And actually our engineers were very worried about it. They thought, am I going to get my work done? What's going to change and everything. So we did invest time and energy to build up the training and support for our most at that time DV engineers, right? We were moving our DV flow over to the cloud first. And so we actually went through, multiple sessions of training everybody on exactly what was changing, what the workflow was changing, how you need to respond, how you need to interact. And what we discovered, some of the problems that we found that was the most difficult to come up with, to solve were the error messages. So when things go wrong, right, you're not used to kind of these error messages, and sometimes they go off to weird logs in the cloud and stuff like that, right? And so pay attention to that in that initial transition. I think that's the, one of the things about moving over there is that you have to have very clear messages when things don't go right, and have people who can guide the way to say, how do you fix these things, right? Otherwise, it can be very frustrating for the first set of people to make that transition.
And I think one of the things that we're seeing that's interesting, and I don't know if it may be different for you guys, but right now the engineers that are using the cloud don't have an account. They have a username and password, and they can log in with MFA, multi-factor authentication, to get to the cloud and do their work as if they're on the ground, but they can't start a machine. They don't have an official account at our cloud provider. In fact, only literally 2 or 3 people do that aren't in the IT department, right? And so, as far as, and then also we've got people that are literally logging in and working interactively on it, like it was a box under their desk and it's on the cloud. And so that's a little different. I think there was a question about that. You people, you log in and work up there, or do you move jobs up? And the answer is, yeah, both, everything, right? That's the thing. Yeah, it's everything, right? And so from one of the problems that we had a team of people that were working on the cloud in our design environment, but the design environment was restricted from a security standpoint. The one thing I should point out, by the way, we did have to re-architect our infrastructure on the cloud because we work with multiple foundries, and some of the foundries don't want you working in the same environment with other foundries. And so we have to make separate clusters for that access. And we wanted to do that in a way that saved us money. And so we had to do a respin on that. But the other thing was, we've got people that were logging into the cloud, but they weren't connected to the ground in the same way. And so the human factor of collaborating with engineers working on IP for us, where we didn't have the collaboration tools in place because they were logging into the cloud. And so that whole, how do I work with somebody that I can't get them on a Teams meeting? And if I get them on a Teams meeting, then it's not that secure. It's a whole security thing, and access to chat and email and all that stuff was a whole problem that we didn't really expect, that we did run into.
Great. Megan, I think I missed a question that I wanted to ask you, or a comment you had about interactivity.
I think it was related to the question that Bob was just mentioning about whether you're logging in or your batch jobs. I think one thing we haven't talked about at all is that, one of the things available in cloud is FPGAs, which is a huge headache to maintain at our own FPGA farm. And especially during the coronavirus, it's like somebody's got to go in and hit the button, and it's like mind blowing. And that's something where we do want to give, in our products, we give customers FPGA images, and it's like, well, guess we got to go buy a board and deal with that. But I think that is a huge thing that we haven't even talked about. That's really powerful in the chip design industry, to be able to access actual hardware that's very unique, like FPGAs and even perhaps emulators in the future. I think that's a really interesting direction that we could take.
Well, I think some of the EDA vendors do offer, their emulators in a cloud model. So, yeah. But sorry, go ahead.
I was just saying, getting that in the hands of our customers, like you ordering this, go log into your Linux. It's running Linux now. Go play with it before you even get the RTL would be great.
Yes. We are out of time. Thanks, everyone. Thank you, Megan, Eric, Bob, Richard, for being here today. And I really enjoyed this discussion. And thank you to all the attendees.